Welcome all to the Research Spark YouTube channel. We are running the analog and linear electronic circuits. So right now we are trying in the unit first, that is the single and multi-stage amplifier. So in this session we are going to talk about the multi-stage amplifier, cascade, cascode and Darlington using the hybrid pi model. Also we'll see the low frequency response of BJT amplifiers, high frequency response of BJT amplifier. So let's see here the multi-stage amplifier. First, multi-stage amplifier simply since it contains the two or higher number of the transistor BJT. That's why this is termed as a multi-stage amplifier. Now it can be connected in different manners, like it may be connected in the series, parallel or the different types. So based on that only it can divide it into the different categories. So here the circuit that you are just watching here, that is belongs to the cascade type of the multi-stage amplifier, since both transistors are connected in series or cascaded. That's why the term introduced, that is cascade. So what is the primary objective to design the multi-stage amplifier is to meet the combined specifications of a given amplification factor, or either it may have the some input resistance and the lower output resistance. So these are the objectives that we exactly wanted to meet with the help of the multi-stage amplifier. So here the cascade amplifier, the objective of this cascade amplifier is to have the overall high small signal voltage gain, or to provide overall voltage gain greater than 1 with a very low output resistance. So if we'll see the circuit configuration, then the input, that is the AC input, we are supplying through the base terminal of the Q1 transistor, and the output of the amplifier stage 1 can be collected to the collector of the Q1 terminal. Again the same output is passing to the base terminal of the Q2 transistor, means the output of Q1 transistor will act as the input for Q2, that is for the second stage. So finally output will be collected to the collector terminal of the Q2 transistor. So that is why we'll achieve the higher amplified version of the input signal. So how will I found the gain of the transistor multi-stage amplifier? So here first draw the equivalent circuit, that is hybrid pi model based equivalent circuit. So how will you draw the equivalent circuit model? First replace the BJT. How will you replace? Simply BJT can be replaced by the two things. One, the resistance of R pi, and another current source of Gm into V pi, having the resistance in parallel with that. So since there are the two transistors, so is to have the two stages and draw the equivalent circuit. Then find out the gain. Gain means V out by Vs, and it will be equal to the Gm1 Gm2 Rc1 parallel to R pi 2 into Rc2 parallel to Ri divided by Ri plus Rs. So with the help of this formula we can find out the gain of the cascade amplifier. Similarly, there is another type of configuration that is called cascade. So here if we'll check, then the output of the Q1 is connected with the emitter terminal of the Q2, and the output is being collected through the collector terminal of the Q2, and input is passing through the again base terminal, which is dividing through the resistor in both of them. Means some of the inputs are passing through this base 1 and base 2. So this is called as the cascade. So the advantage of this circuit is that the output resistance looking into the collector of Q2 is much larger than the output resistance of a simple common emitter. And also again you can draw the equivalent circuit similarly, and the finally gain will be the Gm1 into Rc parallel to RL. Third type of configuration may be the Darlington. So in the some application it would be desirable to have the bipolar transistor with a much larger current gain than the normally. So current gain is wherever the high current gain is required, we can utilize the current Darlington type of multi-stage amplifier. How much gain will it have? So gain simply approximately it will be equal to the beta 1 into beta 2. What is that beta 1? So beta 1 is the beta values of the the transistor first, and beta 2 is the beta value of the transistor second. Beta is simply the beta into IB is equal to your IC. So you can find the value of beta, the with this formula. Approximately the beta is lies almost 100, 200, something like that. Means the gain will be the more than uh, 10,000 times. Now let's see the low frequency response of the BJT amplifier. So what are the things we are going to study here? So how, like we are, since we are talking about the AC type of input, so definitely it may have the some frequency. So with the different frequencies, our amplifier will act differently. So first let's talk about the how our amplifier will react with the lower frequency. Means the signal having the frequency in the range of the kilohertz, 100 hertz, 2000 hertz, or the 10,000 hertz. So in the kilohertz only, that may called as the low frequency signals. So here is your circuit, that is a common emitter based only, and it may have the lower frequencies of signals. So first draw the equivalent circuit and find out the how your signal will pass. So through the simple analysis, if we check, then we can find out the cutoff frequency of any RC circuit, any circuits which contains the R and C. It can be 1 by twice pi of R and C. So since here our objective is to find out the equivalent resistance, because we are going to find out the frequencies which will be passed through the CS, then the means the input side capacitors, CC, that we are going to collect at the collector points, and then CE, that is the bypass capacitor. So let's check the what are the frequencies will pass through these capacitors. Because first question is that why are we using the capacitor? Simply we do not want the any unwanted signals, DC signals. So how we'll remove? Simply by using this capacitor. So let's find out the cutoff frequencies of all these capacitors. So first, how will we find out the cutoff frequencies of uh, input terminal? So again we are going to use the FLS is equal to 1 by twice pi of R into C. So R equivalent RS plus RI. So how will I find out the RI? So draw the equivalent circuit. So RI will be the R1 parallel to R2 parallel to beta RE. Similarly, we can also find out the CC and the CE terminal. What are the cutoff frequencies for these capacitors? So here you can check the values of the FLC and FLE. So with the help of these, we can find out the bandwidth, that is the what are the frequencies can pass through these circuits, through these capacitors. And by combining all these results, we can find the actually what will be the cutoff frequency for this multi-stage for this amplifier. Now let's talk about the high frequency response of BJT amplifier. So here, first of all, why we are talking about this high frequency response? Because if you will check the reactance of any capacitor, then it will be termed as 1 by omega C. Omega is simply your frequency. So reactance of any capacitance will be very high for lower frequency and very low for higher frequency. So since we are talking about the higher frequency, it simply means the capacitor will start to pass all the signals, means it may have the very low reactance. So because of the low reactance, it will feel as the very less resistance, and it will treat it as a short circuit. So because of that only, the some parasitic capacitance will introduce. So that we are going to introduce here the because of the parasitic capacitance, we are going to find what are the higher frequency cutoff with it. So here, towards the input terminal, we can find the cutoff frequency, and at the same time, we can also find out the cutoff frequency for the output terminal. So it can be written as FHI is equal to 1 by twice by RTHI CI. So THI you can find it with the help of RS parallel to R1, parallel to R2, parallel to Rm. All these things can be found by drawing the equivalent circuit. In the next session, we'll talk about the MOSFET linear amplifier, load line analysis, small signal model, analysis of common source, common gate, common drain amplifiers using the hybrid pi model. Thank you for listening. If you have any doubt, please drop your comment. Thank you.